Hello everyone, welcome back to this session of looking into a few examples on calculating time complexity. So in the previous session, we had looked into a few of the for loops where time complexity is calculated. Let us continue with few more examples. So herein I have a for loop where for I is ranging from 1 to n, and look into the value of I is getting incremented by 2. So in case if n is 10, each time I is getting incremented by 2, the for loop will get executed n by 2 plus 1 time. And inside the for loop we have a print statement where print of I again will get executed n by 2 times. So the function f of n will be n by 2 plus 1 plus n by 2, which the highest degree of polynomial is n, so the time complexity is represented as order of n. Here we have another examples where for I equal to 0, I less than and I plus plus, and j equal to 0, j is depending on the value of I and j plus plus, and then you have a statement print of j. So let us see how many times these statements will get executed. Now if you look into the external outer for loop, the outer for loop will get executed n plus 1 time. So let us see this how many times the inner for loop will get executed based on the input of outer for loop. Now here I have for I equal to 0, inner for loop will get executed one time because the value of I is 0. Assume I n is 5. So I is 0 of 0 is less than 5. It comes into the inner for loop. Now here j is 0. J is less than I. It checks for the condition j is not less than I, but this statement is getting executed once. Since j 0 is not less than 0, print statement will not get executed. That is mentioned here. Outer for loop I equal to 0, inner for loop will get executed once. The execution is for the checking of the condition. Condition fails, print statement will not get executed. So statement is getting executed 0 times. Now it comes out again, the value of I gets incremented. So I is 1 now. 1 is less than n. We are assuming that n is 5. So what happens here? We have it comes into the inner for loop. So inner for loop we have j equal to 0, j less than I is 1 now. Here given I is 1, 0 is less than I. So hence what happens? The inner print statement will get executed once. J gets incremented. J becomes the value of j becomes 1. 1 is not less than 1, but this statement is getting executed for the conditional check. That is why we have given here inner for loop is getting executed twice. When the conditional check fails, it comes out of the loop. I gets incremented. I becomes 2. Now 2 is less than n, so again it moves on to the inner for loop. This continues. This is mentioned here. The number of iterations are mentioned here. Now, if you look into this, how many times the inner for loop get executed? For each value of I, we see at the beginning when I equal to 0, inner for loop is getting executed once. I equal to 1, inner for loop is getting executed twice. I equal to 2, inner for loop is getting executed 3 times, etc. So this can be generalized as 1 plus 2 plus 3 plus 4 plus etc. n, which is nothing but the sum of n natural numbers, which is given as n into n plus 1 divided by 2. So we can say that this for loop is getting executed n into n plus 1 divided by 2, which is nothing but n square plus n by 2. Now if you look into the degree of highest polynomial, that is n square, hence the time complexity can be represented as order of n square. Now we will see another example where the value of p is given as 0, and the for loop is ranging from I equal to 1, p less than or equal to n, and I is getting incremented. The statement says p equal to p plus I. So let us again see the number of times a for loop is getting executed based on the value of p. So for loop initially I is 1, the statement is getting executed 1 times because uh, p is 0, I is 1, 0 is less than or equal to n. Let us say n is 5. So 0 is less than or equal to n, we are incrementing the value of p. So the statement is getting executed once for the condition of I1, and next time when I becomes 2, the statement will get executed 1 plus 2 times. So it goes on. It gives So we have a generalized form 1 plus 2 plus 3 plus 4 etc plus k. Now it actually depends on the value of p, right? As p increases quadratically, the value of I increases linearly for each iteration of the loop. Now we can generalize it as k into k plus 1 divided by 2. That is, the function or the for loop will get executed as long as the value of p is less than or equal to n. That is, once p becomes greater than n, it comes out of the loop. So here the value of p is incrementing as 0 plus 1, then 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, etc. That is k into k plus 1 divided by 2, because it is sum of n natural numbers. So once this k into k plus 1 divided by 2 becomes greater than n, it comes out of the loop. That is k square plus k by 2 greater than n, it comes out of the loop. That is k square greater than n, it comes out of the loop, or k greater than root n. So the time complexities can be represented as order of root n. Yeah, that's all for this particular session. We'll come in with a new video with few more examples on time complexity calculation.